Hi, I am Abhishek Agasti, and this is a quick demonstration of my project for assignment 1 in the course Fundamentals of Distributed Systems at IIT Jodhpur. Now, I'll be quickly running you through the project report that I had presented. This is the project report. So I had incorporated all the things that was asked in the question for the assignment. So this is the folder structure, and I had shown the step-by-step processes that was followed, and I had inserted the screenshot for the steps and each as and when they were are required. So I had also inserted comprehensively all the codes for the different files that have been used or incorporated here. So just running through and going through the project report. Now, um, um, now the objective of the project was to implement a distributed key value store that maintains causal consistency over vector clocks and to run it over multiple Docker containers. Now coming to the architecture overview, the I'll first show the folder structure that I've used. So uh, I had created this vector clock kv state folder inside which I had created this folder src and then the docker compose.yml file and a docker file, and inside this src folder uh, we have the client.py file and the node.py file. So I'm now presenting the docker compose.yml file. So here we can see that um, the system is made up of 3 nodes. Each one is a Flux-based Python server running in a separate Docker container. Each node maintains a local key value store, a vector clock, and a buffer message that arrives out of order. Nodes communicate with each other over REST APIs, and Docker Compose orchestrates the full system. I'm also showing the other files, that is the client.py file, and this is my node.py file and the docker file. Now let me now start the system, and for which I've entered the terminal for the docker compose, and I'll enter the commands docker compose down and then the docker compose up build. This builds the image and starts all 3 containers, node 0, node 1 and node 2 on ports 5000, 5101, 5102 respectively. So we can see that in this file, the terminal, the log of this terminal output, the 3 containers have been successfully created and they are running. So now I'm showing the browser tabs while opening all the 3 ports and confirming that all the 3 nodes are running. Uh, yeah, as you can see. Now I'll run my client script, that is the client script.py, and in the terminal I'll type in the command python src slash client.py and hit enter. So this command would run, and this would perform the following causal test scenario. Now the node 0 writes x equals to apple, then node 1 reads x and then later writes x equals to banana. Since the second write depends causally on the first, we expect vector clocks to enforce that order. Now I'm showing the terminal output of running python src slash client.py. Now, let's inspect the final state of each node by visiting their store endpoints. Now we can see that all the nodes have final value x equals to banana and vector clock 1 comma 1 comma 0 and empty buffer. So this proves that the causal relationship was respected across all nodes. Now, um, in conclusion, so like I will also like show the browser views. So in conclusion, this project success demonstrates causal consistency in a distributed system using vector clocks. The Docker-based setup allowed isolated nodes to communicate and replicate data reliably. Finally, I will be showing you the Docker desktop environment. So here we can find all the containers. Now opening the vector clock KV store container. Here we can find all the three nodes in the containers, node 0, node 1 and node 2, and, see that they are running. So yes, so this was uh, all about my presentation and demonstration of my project. Thank you for watching.